Good. Welcome everybody to a new event of our web seminar Wednesday in Composites United. My name is Thomas Heber and I have the honor to introduce our guest to you today. Our guest today with the title, the promising title, and I'm very curious to hear this and see this, is Opportunities Combining AFP, so advanced AFP and Filament Winding in one platform. AFP is automated fiber placement. Yeah, that's right. And our guest today, I'm very happy to have you here, is Chiemi Avila Mori from our French startup Carbon Access. Hi, Chiemi, nice to have you here. You are one of the founders of Carbon Access, right?
Yes, exactly.
Chiemi, it's your second time already that you talk to us in a Web Seminar Wednesday, and now you want to present your the new stuff in your technical development at Carbon Access. As I said, I'm very curious, and the stage is yours, Chiemi.
Thank you very much. Thank you, Thomas, for the introduction and also for the invitation to participate again today at the Web Seminar Wednesday. And thank you everyone for joining today. Good morning as well. And yeah, as Thomas was saying, my name is Chiemi Avila Mori. I'm co-founder at Carbon Axis. And today we're going to be talking about the opportunities combining filament winding and automated fiber placement in one platform. So the agenda for this presentation is going to be divided in four different sections. So at the beginning, I'm just going to give you an introduction to who we are and what are we doing at Carbon Axis. Then I'm gonna go through the difference between automated fiber placements versus filament winding. So we're gonna talk about the disadvantages and advantages of each process and why it's interesting to combine both processes to have a more optimized composite part in the end. So we're going to be talking about the state of the art of the machines and the current situation in the available solutions that are in the industry right now. Then I'm going to introduce you to the XCell machine that we have developed at Carbon Axis. The XCell machine that it's our multi-process solution that we have now. And then finally, we're just going to do a summary, we're going to go through the remarks of the presentation. And I'm also going to be giving you a small teaser of some of the new developments that will be coming for 2026 that we are currently developing at Carbon Axis. So starting with the first section is who we are. So Carbon Axis was founded in 2018 in La Rochelle, France. We are located on the west coast side of France. It's a very, very nice town in France, next to the sea. And it was founded by Pavel Perrotet and me. So we specialize in automating composite process. The visions from the start for Carbon Access since the beginning has been to make composite parts more affordable, more repeatable, and generate less waste through simpler and more efficient automated solutions. So we at Carbon Axis, we provide both hardware and software turnkey solutions that are ready for production. They're intuitive, they're easy to use, easy to maintain at the same time, they're affordable, and they're also robust. So our machines are fully developed and assembled in-house in La Rochelle. So we are mainly machine suppliers. So we supply machines to different customers in different industries. We have material suppliers that are using our machines. We have machines in the aerospace industry. You have machines with industries, different industries, general industries, and also universities. And we also provide R&D services. So we have in-house facilities. So we have two machines at our facilities that can be used to do R&D testings. So we can do material validation, we can do simulations, we can do prototyping, and then we have customers that they want to go sometimes into small series production. And for that, we have some of our customers that now have become partners as well, that they have our machines that they are able to do also the serial production if it's necessary. So that's who we are in Carbon Axis. Now we're gonna go into the second section that is what's the difference between fiber placement and filament winding and how we can work with both of the process together. So as an introduction, I'm just gonna introduce the term for tape winding. So tape winding is the process of using an automated fiber placement head, like we can see in the video, with an external axis. So in this case, it can be a horizontal or a vertical external axis. And the main difference when we are comparing fiber placement with filament winding is when we are using fiber placement, we are always in contact with the surface when we're placing. So the fiber that we're placing, it has some pressure that is being applied by a compaction roller. And as you can see in the video, we're always in contact with the surface when we're placing. Difference with filament winding is that in filament winding you are not in contact directly with the when you're placing, so you are placing in a rotating mandrel under tension. So the advantage of being in contact with the surface, like to use tape winding in this case, is that we have more control on what we're placing. So we have more precision on the toe that is being placed. So we have a layer by layer control. And another advantage is that we can use steering pads. So in this case, we can have pads that are following the load. So like that, you can optimize your layout better. So one of the advantages of tape winding is the more precise control whenever we are placing the fiber in comparison to filament winding. Another difference between tape winding and filament winding is the fiber angle. So in tape winding, we're able to place any angle that it's available. So we are able to place pure zero, so you can see in the picture, or pure 90s. Comparison to filament winding, there's a challenge when we want to achieve angles that are lower than 15 degrees, like the angles that are parallel to the axis. So the shallow angles, it's very hard to place them with filament winding. In tape winding, you're able to place any angle. In this case, there's restriction depending on the head. So you might have some collisions with the mandrels, but in general, like any fiber angle can be placed with tape winding. The main advantage of tape winding is the idea of using local reinforcement. So something that is not possible in filament winding because you are continuously placing, but in tape winding, we are placing each fiber. So we are placing and cutting each fiber, which makes possible to be able to place material locally. So in this case, we just did examples to have, like, for example, a patch to be able to reinforce maybe some inserts. You can also reinforce some domes. So the whole idea is that you can only place material where it is necessary. Like that, in tape winding, you are able to have custom thickness. This is something that is not possible in filament winding. In filament winding, you have constant thickness, and your thickness is also dependent on the winding pattern that you have. So for example, in pressure vessels, you usually have like very thick domes here because you have the turnover regions where the fiber keeps building up. But in tape winding, you're able to create your own ply thickness. You have reduced the part thickness, so you can also have less material. And you are able to create, for example, some ply drop-offs. Like in this example, we have like 4 different layers, as you can see here. And like that, we are able to select like just the material where it's necessary. As I was saying, because we are able to just place locally, we have lower waste on the material that we're using with fiber placement. This is because we don't have the turnover zones at the extremities. For example, in filament winding, when we are winding like a pipe, you have very long turnover zones if you want to be winding like shallow angles at extremities. So the advantage of tape winding is that you can reduce the thickness and you can also reduce the material that you're going to be using. As we saw in this picture, we're placing each layer as a unidirectional layer. That affects on the part quality that we're gonna get from using tape winding. So in tape winding, the part quality is higher because we don't have the crimp between the layers that is formed like when we're using filament winding. So as you can see in this picture, we have a layer of full 45 on the bottom and then a full minus 45 on the top. So there's no layers that are being crimped, like in comparison to the one on this side. So here, like in filament winding, as we are doing continuous winding, we have biaxial angles that layer at the same time. So the crimp is created, and this creates reduces the strength of the final part at the same time. So the part quality in tape winding is better. And another advantage that we have when using tape winding is the part geometry that we can place. So we are able to place in more complex parts. We can do concave shapes, for example. So here, like as we are always, our roller is always in contact with the mandrel, we're able to place directly on the surface and do not have the fiber bridging that we will have with filament winding. So in tape winding, we can do more complex parts, we can do concave shapes, double curvatures, not symmetrical parts that you cannot do with filament winding. However, one of the main disadvantages that we have with tape winding is the position rate. So tape winding is much slower process compared to filament winding. So it's not that you can just say, okay, just want to replace my filament wound part now with tape winding to have more optimal part, because the production cycles, yeah, they're not going to be the same. So the whole idea is not to replace one process with another, is to combine both process. So in this case, we can combine both process, so you can do filament winding, for example, to do the bulk structure, and then use fiber placement to do the local reinforcement. Some applications that we have been looking at is for pressure vessels to do dome reinforcements with fiber placement, and then do the hoop with with filament winding. So we have options like for pressure vessels, dome reinforcement, also for insert, reinforced locally. We have also some parts that they have been, if they are, for example, loaded in tension, they will need some zero directions. So this is quite interesting to combine like filament winding and fiber placement. So we have also been looking at reinforcing connections between parts, so with fiber placement. So usually the high deposition rate it's done with filament winding, and then you just do some fiber placement to do some local reinforce to be able to optimize and improve the mechanical properties of the final part. In this video that I'm showing you, we were doing filament winding at the beginning, and now this is just for a demo, like a prototype that we were just to demonstrate the technology. And now we're doing like some zero directions to show that we can do zeros inside. But the interesting part of this video is that we are using the same material. So we are winding and doing filament winding and AFP with the same material. It's a Torre Topreg, and in the same machine. So it is like the proof of concept that we wanted to show. Nowadays, the problem is that if we want to combine both process, the problem is that you need different machines. So you need a machine for filament winding, and then you need a machine for fiber placement. Sometimes most these machines, they come from different suppliers, which means you have different integration costs. There's also more workspace floor that you need because there's two different machines. You can have maybe more workforce. So you have two operators, one operator per machine, most probably. And then you also have maintenance costs that are higher, integration costs. Everything becomes a bit more, it keeps adding up. One of the problems as well is that it's not so easy to combine both processes, so it takes longer time to production, as you have to do machine settings per machine, per process, and that one can have like differences and also affect the final part. So for this, in Carbon Axis, we have developed the XCell machine. So the XCell machine is what we call a one standardized turnkey platform. The whole idea is to have both process inside the same machine. So we are able to have flexible manufacturing. You don't have to change the part from machine to machine. You always have the same part, and the only thing you need to change is the tool, the end effector that is going to be doing the different process. So like that, we're able to streamline the production. We are able also to reduce integration cost, and also reduce maintenance costs, at the same time reduce the cycle times that will take for the parts. So I'm saying like the XCell machine. So the solution that we have developed is a compact and accessible multi-process solution. A bit of background from Carbon Axis, like Carbon Axis started in 2018, as I was saying before, and we started mainly as an automated fiber placement solution provider. So the XCell was initially developed only to do fiber placement. So at the beginning, we developed the XCell to be only doing AFP. something that we saw is that our clients were being restricted with the kind of parts that they could do. And we were looking into how can we make it more flexible? How can we add more value to the machine, like for the final customer? So something that we were looking into is to have a modular machine that can integrate different process. So in this case, we leave the choice to the final customer to decide how flexible the machine needs to be. So we saw we have already a machine, an enclosed machine. We have a robot, so we can use this robot to do different processes at the same time. So like that, we decided to integrate different process as standardized models. So all these processes are standard optional features for us, and they can be integrated at any time. This is quite important for us to be able to have them as standard modules as well, because the machine since the beginning has already been prepared to take all these different modules. And the whole idea is like that, even if you don't take, for example, filament winding at the beginning, if you want to take it after, then it's not going to cause loads of integration because the machine has already been prepared to take that module. So it was something that we wanted to have for the client to be able to reduce integration cost and also like the investment that they will do. So in this case, we developed the XCell, as we can see here. And the different modules that we have now are the following. So we added an automatic tool changer that is quite important because now we have different process. So each process has a different end effector. So in able to change fast between them, then we needed an automatic tool changer. So that one is the base for the modular modules that we have. Then, as I was explaining before, the XCell started as an AFP machine, mainly to do flat and 3D parts. And then we added the horizontal axis that we can see in the picture here to be able to do tape winding. When we were looking at tape winding this year, now we launched our filament winding. So we developed a small head that is now available, and it's a head that it's a single toe for this XCell machine and can have a tension per toe up to 40 newtons. So we are using the same horizontal external axis that we developed for the tape winding. So we just added developed a new head to be able to add the new process. So now we have tape winding, filament winding. We also have the option for ultrasonic cutting. This is quite important for customers that they want to have net shape preforms. So they want to have the preforms already ready to be used for closed mold production. This year we also added a 3D print extruder. So we have the option to have a filament extruder, but also a pellet extruder. And this is like we have different customers that they want to combine the 3D printing, for example, with thermoplastic materials, or they want to 3D print molds and place on top of them. So it's optional with the different configurations that you could do. And finally, we have the Industry 4.0 connectivity. This is quite important nowadays as well to be able to have a machine that can collect data. So we have an OPC UI server that enables the user to collect the data from the machine while it's doing the process. So for example, we are able to collect robot speed, robot positions, and during AFP, we're able to collect, for example, the pressure being applied, the heat power being applied. Filament winding, we're able to check the tension. And this is important to know what is happening in the process. You can also use this data and analyze it to create a digital twin at the same time. But also for production, it is good to have a production log of how the part was manufactured. So the XCell, we have developed it as a standard turnkey solution. It's a machine standard turnkey solution, so it comes with machine and software. Something that we have been working a lot on this machine is to have a balance between custom and standard machines. So we have developed one machine and now have different sizes. So all the standard modules, the process that we saw that we have in the previous slides, they're available for all the machines, different machines that we have. So the first machine that we developed is the XCell machine. You can see here. It's a machine that it's about 2 meters by 2 meters. It's an enclosed machine because we have a temperature regulated environment inside. So we have a small cooker robot inside this machine, and you can see on the side here we have a krill system. The krill system enables us to use any standard spool. This machine was mainly developed for the manufacturing of small parts. So we are able to manufacture parts for AFP about 1 meter times half a meter times half a meter. And then when we're using the winding, it's parts about 700 millimeters length and 50 centimeters diameter. So it's a machine that is very good for the manufacturing of small parts or also for R&D environments. It's because you can work very close to the machine, and it's also very good for material testing or validation prototyping. However, now we were looking into the production, we saw there's a need for bigger parts in composites. So this year we launched what we call the XLM. The XLM is a machine that can do parts that are bigger than 1 meter. In this case, the XLM doesn't have like a standard size, like the XL here on my left, it has a standard size. The XLM, it can be custom. So here we can customize from the different component catalogs that we have. So you can customize the length of your machine and also the layout of your machine. So you can adapt to different production demands. This is a machine that we have in our facilities at the moment. It's a machine that is about 4 times 3 meters, and it can do parts up to 2 meters length. So the whole idea with this is that we have custom machines, but we are always using our standard modules or like ready available components. So in this case, we have a customer that is mainly doing AFP for parts that are about 1.5 meters or 2 meters length. So we developed a machine for them about 3 meters by 3 meters. So like that is able to place on it. And for example, on this side, we have a customer that wants to do parts of 5 meters length. In this case, we need to mount the robot also on a linear axis to be able to achieve those lengths. And this is a machine that can do, as you can see, it can do flat. It can do also winding. So in this case, for the XLM, whenever we go into the parts that are bigger than 1 meter, we can adapt depending on the production demands of the machine. So we can have a custom layout, still using all our standard models. Because we are doing a modular machine, we also have to think that our end effectors, the tools that we're using, they have to be modular. So it is important to have them modular so you can scale the solution for us. So in this case, this is the AFP head that we developed for the small machine. You can also mount it on the big robot. And the whole idea is that with this head, like the X-place head that we call, you can do parts that you can use different materials. So we're able to process thermosets, thermoplastics, and also dry fiber materials. And you can do within the same head different widths. So we can go from widths from 1 mm up to 1 inch with this simple head. Something that we saw with some fiber placement heads that are available in the market is that sometimes they are constrained by the type of material that you can use. And that includes the type of spool packaging that you have. And for us, we didn't want the clients to be stuck with only one type of packaging or to have to respool on their side because that one also takes a longer time. So we're able to take on any spool packaging. So we are able to take the 3-inch spool, the classic ones with different lengths, and the Hafner spools as well in different diameters, as you can see in this picture. And then in this one is a diameter of about 600 mm. So for us, it's important that our tools can also process different materials, different widths. They can adapt to the packaging to be able to provide more flexibility to the final customer. In this case, we have here our developed head that it's also for AFP, that it's a 4-toe head that I will show you a bit more information on the final slide. And then just to show you a quick video, like the machine adapts to what you need. In this case here, in that one, we were using thermosets fiber placement. We have a machine doing filament winding. And then on this one, we have a machine that has different like spool. So we are able to adapt the machine depending on what the client needs. As we were talking about, like we provide machine and software, and our software also needed to be uh, in a way being able to have all these different modules inside the same software. So we have developed an all-in-one software solution. It's called the XLA. XLA, as you can see, it's a plugin that we have developed for Rhino zero 07. So we have one single interface for all the different modules that we have. So in this case, we are able to do AFP in XLA. We are able to do Extreme with ultrasonic cutting and X-Wing for tape winding. And in the next slide, I will show you what we are doing at the moment for filament winding software as well. So XLA is a very simple and intuitive interface. You can do everything within the same interface. So you can design your part in Rhinoceros or also import it. Then you can build your layup. It's a very easy and like a real-time software that will show you exactly what you are building at the same time. You can change different parameters. So the whole idea is you build your layup, then you do your offline programming. In your offline programming, you only have to define your machine settings, some of the parameters, some speeds that you want to change. Then you have here on the next slide here and offline, then you do your machine settings, then you can do your robot simulation to check that everything is working well. And once you start doing your robot simulation, your machine code is generated at the same time. So you have everything in one single interface. The machine is already ready to be run in the Excel machine. You don't need to add or change anything to the code. So depending on, for example, what materials you're using, what heat source you're using, everything is updated on the post processor. There's no need to add or change anything on the code. So we have the same thing for Extreme and Xwind. And something that it's also we wanted to have the flexibility in XLA is that you are able to change the different machine configurations that you could have or different robots. For example, we have some customers that we also have the option for the fiber placement head as a standalone version. So we have some customers that they got the standalone version because they already had some existing robots. But the whole thing is they have two different robots, and sometimes they were mounting the head in in each of them. So the whole idea for us was that they could easily change. In this case, for example, they're using a small robot, but then they wanted to use the other robot for the next day, so they could easily change the robot they're using, adapt the base, and then it's very simple to do all these machine configurations. You don't have to reset or import any different value. Finally, we have what we have developed at the moment for filament winding in XLA. So we have developed a post processor that works for CAD and composite files. At the moment, we mainly have the post processor because most of our clients, they already have filament winding softwares. So they were working with CAD composite CAD, and some are working also with CAD fill. The whole idea is the same. You use one interface to be able to import your part and then generate your machine code for the Excel machine and also have the robot simulation. This is quite important because most of these CAD and composite CAD softwares, unfortunately, they don't have the robot simulation, which it's a bit hard sometimes to know that the part can be properly manufactured. Like sometimes there's some axes that might have some collision with the mandrels, depending on the settings that you have used. So the whole idea for us is that you can import your part, you can see the robot simulation, be sure that everything is okay, and then you can run your part directly on the machine. So how it works, you just have to load, import your part, you import the mandrel you create. It will show you the circuits that you have per ply. You can change the width of the circuits to just to check that everything is the same as you had it in your other software. Then you can check how is the mandrel inside the Excel machine, and then you can start doing your simulation. Oh, sorry. Okay, we're back. Sorry about that. So yeah, so you can see your robot simulation exactly what the robot is going to be doing for the first circuit, for all your circuits. In the bottom here, you have the code that has been generated and is the one being run in this video to be able to show you what we're doing. Like with the post processor, what we get, the information that you get is the information that you in the simulation is the trajectory that the robot is going to be following. So this is quite important, like to be able to have the robot simulation to see like there's no collisions. In the next example, we're going to be using, for example, in this one, you can adapt the mandrel. You can change the mandrel to the position where it is in the machine, that we will see in the video here. And then, for example, in this example, we're using a 5-axis, we're using the yaw axis. So we need to make sure that the head is not colliding with anything in here. This is quite hard sometimes in the other software. So for us, it was important to be able to display that. So as the summary of this presentation, it's just saying what we have been talking, like combining filament winding and automated fiber placement. It can improve efficiency and the strength of final parts. It's important to have a one platform because it can result in faster implementation, streamlined production. And as machine manufacturers, we need to have modular designs to be able to have flexible manufacturing and to have scalability to be able to simplify all the composite manufacturing. And as I was saying, the upcoming developments that we have for 2026 that we will be showing more during JEC. So if you go there, please visit us. So we will have a multi-toe, four-toes AFP head, as we saw it in the previous slides. We also developing a multi-toe, four-toes filament winding head. So these heads are going to be mounted on the big robots for the XLM. And we are also developing a full filament winding software. It's not just a post processor, so it will also have the option to do your circuit planning inside the filament winding software. So I just want to thank you for attending this webinar and for the opportunity to present what we have been developing in this year, like at Carbon Axis. And if you have any question, please do not hesitate to contact me. Thank you.
Thank you very much, Chiemi. It was a nice and impressive presentation, very fast and a lot of information. And it's really what you have there developed in the last year, a very impressive technology. I haven't seen that before, this kind of combination, very, very impressive.